All right, so the last section for this week, it's 9.4 in your book, but if you're following along in the packet I gave you, it's 6.2. Okay, so all page numbers for homework for this section refer to your packet, not your textbook. All right, so there's 4 basic conic sections you can look at. And conic sections basically have to do with the ways you can take a cone and slice it, and then look at the cross section. So the simplest way you can take a cone is just to take it, slice it perfectly straight, and then look at the cross section you get, and that's a circle. Now, kind of a similar idea, but if you slice it on an angle, but make sure that the slice goes through the sides, it can't come out the bottom. Okay? If the slice goes through the sides on an angle, you get more of an oval shape, which we call an ellipse. Right now, if you slice it again, but this time when you slice it, your slice goes through the bottom of the cone, that's when you get a parabola. Okay, and the last conic section you can get, you really need to take 2 cones and put them together and slice it vertically, straight down. Okay, and that shape is a hyperbola. Right, so we've talked a little bit about circles. So we're not going to study that conic section too much. We're going to really focus on the parabola, then the ellipse, then the hyperbola, those 3. Okay, any questions on just kind of the general idea of what the 4 conic sections are? So today we're going to look at the parabola. Okay, each conic section has its own set of terms. There's a lot of vocabulary with different things, like maybe a vertex, directrix, major axis, minor axis, all kinds of terms we're going to learn. So we'll go through all the vocab to start. I'll show you an example of a parabola, and then we'll practice solving some problems. Okay, most of the problems are going to be more descriptive than graphing. Okay, we'll do a little graphing, but a lot of it, I'll give you an equation, and I'll say, tell me where the focus is. Okay? Tell me where the center is. Tell me where the vertex is. Things like that. Right? So we just have to learn what to look for in the equations. All right. So that's the definition of a parabola. Okay, so I'm going to leave that up there so you can copy it for a second. All right. And I think before I read this off, it kind of helps if I maybe define something simpler first, and then we'll look at this one. So if I were to define a circle, okay, a circle's a little simpler. I would say a circle is a collection of points in the plane that are all a fixed distance from a center point. That's it. We call that center point the center of a circle. Well, parabola is a little more complicated. Okay, it's still a collection of points in the plane that are a fixed distance from a certain point, but they're also the same distance from a certain line. Okay, so in other words, if you pick any point on the parabola and measure the distance from that point to a special point we're going to call F, and then measure the distance from that same point to a special line we're going to call D, the distances come out the same. Okay, and I think the easiest thing is just to show you kind of with something I can move around on the screen that's a parabola. All right, so what I have here is a parabola. Okay, it's a specific one. And point B is a point on the parabola. This line up here is that line is what I call D in the definition. And A, okay, if you want to look at what I called it in the definition, I used F. So I'm going to measure the distance from a point on the parabola to point A, and then the point on the parabola to that line. Okay? And this thing up here is going to update. Okay? These 2 things, as I drag my mouse, should update. I might have to do it. Oh, I can do it here. So notice what happens as I drag point B. The distance from point B to point A and point B to point C stays the same. With rounding, sometimes it gets a little bit a little bit messed up, or I might have messed something up. Yeah, I think I might have accidentally moved the parabola a little. But the two distances should stay pretty much the same. Okay, those two distances. So any questions on that? That's the idea of a parabola. You can measure those two distances, and they always stay the same for any point along the parabola. And parabolas can be opening 4 different ways. This one's opening down, but they can also open left, up, or right. Okay? And based on the equation, we can figure that out. Okay, so that point I called F, the reason I called it that is because it's called the focus. It's called the focus of your parabola. And D, that line that we measured the distance from, that's called the directrix. So every parabola has a focus and a directrix. We'll see some other conic sections that have a focus in them, or foci, it'll have 2. But there's no other conic section that has a directrix. Parabola is the only one. Okay, so we won't see this term again after today. All right, so figure 3 is basically what I just showed you with this. So if you look at figure 3 in your book, it's just showing you that this distance and that distance always come out the same. All right, so you don't have to look at that figure. Okay, if you draw a line right through your focus, but perpendicular to the directrix, that's the axis of symmetry. Okay, so here's our focus. Here's directrix. Okay, remember, the focus would be, think of the parabola, it wraps around the focus. Okay? So your focus is always inside the parabola and it wraps around it. So the focus might be somewhere in there. If I draw a line through F, perpendicular to my directrix, it gives me my axis of symmetry. Okay, so it cuts the parabola into 2 symmetrical parts. The point where my axis of symmetry crosses the vertex, that point right there, that's my vertex. So another way to think of the vertex, it's like the point that is the highest in the parabola, or the furthest left, furthest right, or lowest down, depending which way it opens. Any questions on the definition of a vertex? Okay, as we study some other conic sections, you'll see that sometimes you have 2 vertices. Okay, in certain conic sections, parabola only has 1. Okay, so we won't see plural today, just a single vertex. Okay, and there's one more distance that we can measure. And it's not a distance that's used a lot, but you might see it in the book. It might ask you to find this distance. If you see this in a homework question, you can ignore it because I don't want you to spend too much time worrying about it because it's not on the test. But if you measure the distance across the width of the parabola and you measure it at the point that goes right through the focus, they call that the lattice distance or lattice rectum distance. I don't know where they get the name. It's what it is. Okay, so the lattice distance, that's the width of the parabola measured through the focus. Because of course the width is always changing as it goes out more and more. And so again, if you see a problem in the homework and it asks you to find the lattice distance, don't worry about that part of the problem. Okay? But I just want you to know what it is. Okay, questions on that? So now we're going to look at how we can derive the equation of a parabola. Okay, I told you parabolas can open how many different ways? 4. We're not going to derive all 4. We're going to derive one, and you could derive all the others, basically doing exactly the same thing, just taking the whole proof we're about to do and turning it on its side. All right. So I'm going to draw a parabola. And to make it simple, I'm going to put the vertex at the origin. Okay, my focus is going to be point F, and I'm going to put it on the positive x-axis. All right, so here's our diagram. There's a couple things I can move out of the way for now. Right, so I have my x and y axis. I drew a parabola opening to the right. The focus is inside the parabola because, again, parabola has to wrap around the focus. And I don't know how far to the right to put my focus, but I know it's on the positive x-axis. So any point that's on the x-axis would have to have a y-coordinate of what? 0. Okay, so I know that. So there's the coordinates of my focus. I went to the right a units. And I didn't go up and down. And then I just picked a random point anywhere on the parabola. Call it point P. Now, if I measure the distance from the point to the focus and from the point to the directrix, what do I know about those two distances? They should be equal. Okay, that's what we wrote right here. The distance from the focus to the point and the distance from the point to the directrix is the same. Right, so we can put in a tick mark showing those two distances to be equal. And that's basically the concept to find out the equation of a parabola. Calculate the horizontal distance, calculate the distance from P to the focus, and set the two distances equal. And that's it. We'll have our equation. All right, let's start with the harder distance from P to F. Any suggestions here how I could add to this diagram a little bit? Maybe to make it into a certain shape? Yep.
Go, take a straight line and go from P to the axis of symmetry down a 90-degree angle.
Yeah.
Down.
So let's draw an altitude, basically, making a triangle. And it's perpendicular. And now the side that I really want to find is the what in that triangle? It's the hypotenuse. Okay, let me draw that triangle just off to the side so we can focus on it. What's the height of that triangle?
Y.
Yep, I went up y. How do I know that? This point at the vertex of the triangle is at a height of y. Well, we don't know that the altitude comes down right in the middle. Yeah, the whole distance here is a. From this point to this point is a. Well, this first part right here is x. How do I know that? Because point P went to the right x units, and point P is lined up vertically. So this part is x units. The whole thing is a units. So Aiden, what'd you just say?
A minus x.
So the bottom is a, take away x, and then you're left with the bottom side of the triangle. Okay, that's the hardest thing to figure out in this proof. And now we'll just use the Pythagorean theorem to calculate the distance from P to F. Okay, we could just pick a letter for now. We could call it C. Okay, but we're going to have an answer for it in a second. Right, what would my Pythagorean theorem look like? Actually, you know what? Don't even call it C. You don't even need that. Let's just set up the Pythagorean theorem. Just set up one side of it. Yep.
Oh, just up one side?
Yeah, just one side.
You want me to set up the side with the y and the a minus x? Or?
Yep, with this
yeah,
diagram.
It'd be y squared plus, in parentheses, a minus x squared.
Yep. And we know that that distance is equal to the distance from P to the directrix. Now that distance is easier to find.
Because the arm forms
And I'll give you a hint. Okay? The vertex is always centered between the focus and the directrix. Okay? Your vertex is always, because think about it, the vertex is a point on the parabola. Any point on the parabola is the same distance from the focus, and it's the same distance from the directrix. So, what do you think the distance is from the point to the directrix? All right, well, it's definitely, we're going to use x, but not 2x. Yep. Yep, it's a plus x. Okay. How do I know this part is a? Okay. Well, it has to be a, because any point on the parabola is the same distance from the focus as it is from the directrix. Well, if the vertex to the focus is a, then the vertex to the directrix is also a. So this part is a, and this little part right here, that has to be x, okay? Because we just labeled it on the bottom. So it's a plus x or x plus a, same thing. Right, so I'm going to set those two distances equal. The distance from the point to the focus, okay, which is y squared plus a minus x squared. Actually, that's not the distance. What do I have to do? I have to take each one, square them, add them up, and then, yeah, don't forget the square root of the Pythagorean theorem. And that's equal to the distance from P to D, x plus a, or a plus x. Now I'm just going to put it in absolute values, just in case we had this parabola drawn in a different direction, where things could end up being negative, okay, if we measured them. So it's a distance. We just want to make sure it's equal to a positive number. All right, what could I do to both sides to start to simplify that?
Square.
Yeah, we could square both sides. And now, if I square what's on the right, I don't need absolute value anymore. Anytime you square something, it's always what?
Positive.
It's always positive. Okay, so now we'll just do out our algebra and see what we got. So we got y squared. What's a minus x squared?
A squared minus 2ax. X squared
Plus y squared. And what's x plus a squared?
X squared plus 2ax plus x squared.
Plus what?
A squared.
Plus a squared. Now, do you see anything in common on both those sides that we could subtract?
Yep.
X squared.
Yep, if you subtract x squared, that's gone. And if you subtract a squared, that's gone.
And 2ax,
Then
and
it's
a
just
positive
gonna be-
negative on each side.
Yep. So we could
Y squared equals 4ax.
add 2ax and move that. And now we get what, Brian?
Y squared equals 4ax.
Yep, y squared equals 4ax. Okay, so that's the equation of a parabola with the vertex at the origin. The focus is on the positive x-axis, and it's opening to the right. Okay, and if you look at your packet I gave you, that's in a table on page 381. Okay, and they have all four of them. They have y squared equals 4ax, y squared equals negative 4ax. Then they have x squared equals 4ay, and x squared equals negative 4ay. Okay, one way you can very quickly tell that an equation is a parabola is one of the variables is squared, the other one is not. When we study ellipses and hyperbolas, the y's are going to always be squared, and the x's are always going to be squared. So it can be hard to tell a hyperbola and an ellipse apart, but parabolas really stand out. One variable is squared, one variable is not. Right? And using this chart, we can basically figure out anything we need to. All right? Any questions on the equation we just derived? Okay, that's the only one that we're gonna do. All right, so when we're graphing a parabola, okay, one thing we want to try to find is the focus. Even though the focus isn't actually part of the graph, it's inside the parabola. We're going to try and find it. Okay, vertex, we definitely want that for our graph. Directrix, again, it's nice to find it. It's not actually part of the picture. And then once we find a point that's the focus, sometimes it's helpful to either find a point to the left and to the right to help make your parabola, or if you have your focus, sometimes you want to find a point above and below to help make your parabola. Okay, but the point is just plot a few points and figure out which way your parabola should open. And that's pretty much it. Okay, so whether you find points left and right or above and below, just depends on which way the parabola opens. All right, so we'll try a few where we graph them, and then we'll try some where I just give you an equation, okay, and I just say discuss it. Okay, I'm going to say tell me everything you know about that parabola just by looking at the equation. Okay, but we'll try that one in a second. Okay, let's try to graph this one. Okay, it says find an equation of a parabola with the vertex at the origin, and the focus is 3, 0. All right, so first thing I want to try to figure out is what equation am I using? Well, if I were to start to graph it, so vertex is at the origin, focus is at 3, 0. Which way does this parabola have to open? It has to open to the right. Okay, it has to wrap around the focus. All right, so now what I would do is look up, and you can use the table. Okay, I would put that on your reference sheet. Find the row in the table for the one where the parabola opens to the right. Okay, it's the first row. What's the equation for a parabola opening to the right? It's right in your table. Okay, y squared equals 4ax. Okay, and what's the format for the focus? It's what letter, comma, 0? It's A0. So because they gave me the focus, what letter did they give me? They gave me A. Okay, I know A is 3. Right? But you have to be able to figure out that 3 is A. Any questions on that? Now what do you think we do with the 3? Yeah, just take and plug it in for A. That's the equation of your parabola. Y squared equals 12x. Now, if we were going to graph it, we would have to rewrite it like this. Y equals what? Okay. I would accept either answer on the test. either leave it just like that, or on the test, they might sometimes rearrange it like what's on the right. Okay, so you have to recognize these as being the same thing. All right, let's graph it. All right, so when we graph it, let's try to pick a number for x that would make this calculation easy to do. So we know we're going to have to take the square root of something. What's a good number I could pick for x?
12.
I could do 12. It would go off my grid. That's the only problem.
3.
3. Okay, if x is 3, what's y?
Plus or minus 6.
Plus or minus 6. Okay, if you plug in 3 for x, 12 times 3 is 36. Square root of 36, 6. And negative 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. I think if I'm asking for a sketch, that's enough. Just sketch it the best you can. That's our parabola. Now, where would the directrix be? What's the formula for the directrix in a parabola opening right? X equals what? Negative a. So the directrix is at x equals negative 3. X equals is a vertical line right there. That's your directrix. Okay. Any questions on that? All right, so I always try to figure out which way does the parabola open, and then it tells me which formula in the table to use. Okay. All right, this not a graphing one. Just discuss it. Now, in order to discuss it, you might want to rewrite this a little bit. Not with a square root, but every equation. If you look at your table, what number is in every single equation?
4.
A 4. So what I'd really like to do is rewrite this with a 4, so I can see what a is. 4 times 2 x. So what's a? 2. That's an important step. Any questions on how we got a equals 2? If you're writing it in the standard form that the table gives you, it has to be y squared equals 4 times something. The something is your a. Right? Normally, you should simplify it, just like we did here. But if you work backwards, it would be 4 times 3. That gives me 12. That's how I know a is 3. 4 times what is 8? 2. Okay, so a is 2. And now just use our table. What's my vertex for this kind of equation? Yep. We haven't talked about shifting it yet. So vertex is 0, 0. What's my focus?
It's 2, 0.
2, 0. Right. Which way does this parabola open?
Right.
I know it opens right. Y is the variable that's squared, and the number here is positive. Okay, so just use your chart. When y is squared and the number is positive, it opens right. And the directrix has to be on the other side of the vertex, but equidistant. And it's x equals negative 2. Okay, is there anything else we could? Nope, that's it. Okay, so when I ask you to discuss a parabola, these are the key things you need to mention. Vertex, focus, which way it opens, and directrix.
How do you get the directrix?
The directrix, I just use the formula. It says for this equation, it's x equals negative a. So if a is 2, it's negative 2. Yep. A is always a positive number. Okay? It's either the 4 or negative 4. But don't ever make a negative 2. Okay? And they tell you that in the table. A is always greater than 0. It's the 4 that would be negative if there's a negative involved. Not a. Okay. Questions on equation 2? All right. Okay, x squared equals negative 12y. Let's just rewrite it first. How would I rewrite that so I can identify A?
Parentheses 3y.
One more time?
Negative 4
Mhm.
in parentheses 3 parentheses y.
Perfect. X is squared. The number on the other side is negative. Which way does a parabola open in that case? Down.
Down.
X is squared. Number on the other side is negative. We open down. The format of the focus when it opens down is 0, negative A. Let's identify A first.
A equals 3.
A is 3.
That's 0, negative 3.
Yep, the focus is 0, negative 3. How about my directrix?
It's just x equals 3.
Careful.
Y equals 3.
It's y equals.
Wrong, sorry, yes.
Okay, I'm just going by what the table says, but you'll see why it has to be a horizontal line this time.
Sorry. I know.
Yeah, because it's opening down, and the parabola can never cut through the directrix. Okay? If your parabola opened up, left, or right, it would cut through a horizontal line. Okay. All right, anything else? Vertex.
0, 0, 0.
Yeah, anytime it's just x squared and just a 4, negative 4, and then a number and a y, it's always 0, 0. Okay, you'll know when it's not 0, 0.
When you're splitting up to solve for A, does it have to be like in a certain order? Like, can it be 3, negative 3, 4?
Usually when we write it, we put 4ay or 4ax. Usually the 4 is first. Yep. And then the a is the coefficient of what's right next to y. Okay, let's try to graph it. They didn't ask us to, but let's just practice it. Vertex is 0, 0. Focus is 0, negative 3. So I know it has to wrap around it, so it comes down. What would be a good value to pick for, a little different, but we're picking a value for y. Actually, parabola would be undefined at 3, because it doesn't open up.
Yeah, I realized
Negative
negative 3.
3. Okay, if you plug in negative 3, what's negative 12 times negative 3? And what's the square root of 36? 6 and? So if y is negative 3, x is 6 and negative 6. Okay, so if we go down 3, we go right 6 and left 6. There's our parabola. Okay, so that's a little different. We normally don't pick a number for y and solve for x. But if the parabola opens up or down, you do. Okay. Any questions on that? All right. Okay, this time I want you to find an equation of a parabola with the focus at 0, 4, and the directrix at y equals negative 4. Okay, what do you think we should try to figure out first about the parabola? Yeah, if we can figure out the direction it's facing, then we're all set. Okay. So I would graph everything they give me and use that to help you. Okay, remember, parabola has to wrap around the focus, and it has to bend away from the directrix. Okay, so where's my focus? 0, 4. Where's my directrix? Y equals negative 4. Okay, I'll label it so we don't get confused. That's the axis. That's the directrix. So if my parabola is going to wrap around the focus, bend away from the directrix, it has to open which way? It's got to open up. And if the vertex is exactly equidistant between the focus and the directrix, where does the vertex have to be?
0, 0, 0.
Yeah, it has to be same distance from the focus and the directrix. That's the definition. So now we know it's at 0, 0. We got our table. It opens up. What's the equation of a parabola opening up?
X squared equals 4ay.
X squared equals 4ay. Only thing I have to figure out is a. And keep in mind the focus, they gave me that, so what's my value for a? 4. Okay. The focus, if you read your chart, is the form 0, comma a. 0, a. So a must be 4. So what's my equation?
50x squared equals
16y. Which, again, could be rewritten like this. These are both correct. Okay, any questions on that one? Okay, how about if I wrote it this way? Is this correct? Yeah, it's the same thing. I just moved the 16 to the other side. Okay, so make sure when you're solving it, if it's a multiple choice, you have to recognize it in different forms. Maybe the 16 is moved to the other side. In fact, if we were going to graph it, this is how you'd have to do it. Get y by itself. Okay. Questions on that one? Okay. All right, let's try this one. And then we'll start to look at what happens when we shift it and the vertex is not at the origin. Okay, it's not that much harder. All right, so vertex is at the origin. Axis of symmetry is the x-axis. And I'm telling you the point that it contains. Okay, from that, I think we can figure out which way it opens. Here's my vertex. And it contains the point -0.5 up 2. And the axis of symmetry is the x-axis. So because the axis of symmetry is the x-axis, it can't be opening up or down. Okay, it has to either be opening left or right. So which way does it open in this case? Yeah, it has to open left. If it opened right, it would never go through that point. Okay, so it's got to open like that. Right, so it opens left. What's my equation for a parabola opening left?
Y squared equals -4ax.
Yep. Y squared equals -4ax. What letter do I have to find? I have to find a somehow. But they did not give me the focus. They gave me a point. So how can I get a? Yeah?
Since that point goes to the line formed by the focus, wouldn't 2 be A?
Well, this is just a point on the curve of the parabola somewhere. The focus is somewhere, it could be somewhere in here. We don't know that that point lines up, in a straight line with the focus. The focus could be further out. We don't know. Yeah?
Plug them in for x and y.
Yeah. This is x. That's y. Okay. Fill those in for x and y, and then you'll have a. So what's 2 squared? And then I have -4 times -0.5. Whoops. Sorry. -4 times a times -0.5. What's -4 times -0.5?
2.
So what's a?
2.
So in this case, a did come out to 2. But in general, that's how you want to do it. Plug the point in. If the x hadn't been -0.5, we would not have gotten 2 for a. Okay, come on. So what's my equation for the parabola? -8x. Okay. Any questions on that one? Yep.
We need
Yep.
to go up to Smash.
Yep, that's okay. Okay, so if you do have to leave, the video will be online and the homework is in the packet you already have. All right, so last thing we're going to look at is what happens when we shift it. Okay. Now, if you're going to put a table on your reference sheet, this is probably the table to put. Because if you don't shift it, all we have to do is block, just let 0 be the values for the vertex. So your vertex now isn't necessarily at the origin. It's at h, comma, k. All right? So this table basically summarizes everything that happens for you. Okay? So we really don't have to think too much about, okay, wait a minute, I shifted it to the right, so that means my directrix is going to be shifted to the right, okay, or something like that. Okay, we have all our formulas here, we just have to follow the formula. Right, so h is the horizontal coordinate of your vertex, k is the vertical. Notice you still have a letter squared, and the other letter on the other side is not. You have positive 4s and negative 4s. The only difference is now sometimes you could have plus or minus inside the parentheses with the x or y. Okay, it could be x minus h or x plus h. Okay, it could be really either one. But what we have to be careful of is we always write it as minus, right, when we're trying to think about it. Right, so if I get a problem that has a plus in it, I'm going to rewrite it as a minus so then I can figure out which way it's shifting. Because h is always the number after the minus sign. K is always the number after the minus sign. So if you had something like, if I just make one up. Let's just say x minus 3 squared equals 4y plus 2 squared. You have to be very careful when you identify x and h here. Did I forget the a?
Yeah, you forgot to put the A in.
No, a is 1.
Oh, yeah.
In this case, yeah. I just thought a would be 1. All right, so in this case, you're okay. Number after the minus sign, h is 3. K is not 2. K would be what? Negative 2. Okay, so if it helps, think of it as y minus minus 2. It's the number after the minus sign. That's k. So just be very careful if they put a plus sign. Right, so I just wrote that down again. Your vertex is at h comma k. Okay, and remember, a is always the distance from the focus to the vertex. Now before, we could say it was the distance from the focus to the origin, because the vertex was always at the origin. Now it's not. Okay, so a, think of it as the distance from the focus to the vertex. You could also think of it as the distance from the vertex to the directrix as well. That's the same distance. Yep. But vertex is not necessarily at the origin anymore. Okay, and you have this whole table on page 383. So if you need it, we'll just look it up right there. Okay, if there's anything you can't read on the table, I would double check with what I have on the board. On your table, the plus sign looks a little faded to me on page 383. It should be h plus a comma k. Everything else I think is pretty readable. Good. Any questions on that? Right, so now when we want to write an equation of a parabola, there's 3 variables you need to find. A, H, K. we need all three. Okay. First thing I'd like to figure out is what's the template I'm going to plug into. To do that, I figure out, does it open up, down, left, or right? Okay. Where's my focus? 0, 3. Where's my vertex? -2, 3. Which way does this parabola have to open?
Right.
It's got to open to the right. It has to wrap around the focus. Now I'm going to look up my formula for parabola opening right. What's the formula for parabola opening right? Y minus what?
4ax. Or
Y minus k squared.
Yeah, y minus k squared equals 4a parentheses x minus h. Okay, so we need to identify a, h, and k. Okay, what's since this opens to the right, what's the format for the vertex? What are the order of the letters? HK. So H comes first, K comes second. Always. So what's H? And what's K? All right. So last thing I need is A. I think the easiest way to find A is use this fact. A is the distance from the focus to the vertex. What's the distance between those 2 points? 2. They both line up horizontally because the y values are the same. One's at 0, one's at -2. They're 2 units apart. And if you have that, you're basically done. Just fill everything in. All right, so it's going to be y minus what? 3 squared equals, yep, plug in the 2 for A, 8, and then be careful with this part. Right. I would like you on a final answer to simplify into that. It's x minus minus 2. Okay, the test is going to focus primarily on parabolas at the origin. But I'm not saying you won't have at least maybe one like that. Vertex at the origin. Okay, any questions on that one?
I get A now.
A is the distance between the vertex and the focus. So I graphed them, and the distance between those 2 points is 2 units because they line up horizontally. Yep, they're always going to line up horizontally or vertically. So you just have to look at the difference between the numbers that aren't the same. It's 2. Right, so in general, I already kind of explained what to look for a parabola. There's 2 variables. One of them is squared. One of them is not. Okay? That's what you look for to find out if something's a parabola. Sometimes what they might do is give us an equation like that. Does that equation I have there look anything like this one?
No.
Does it have the parentheses in it? It's got the x and the y on the same side. That should never happen. They should always be on separate sides. So in order to discuss this equation, I need to fix it. I need to make it look like it should. Okay? And in order to do that, we have to complete the square. Okay? You have to have something squared. Okay? If you don't have that, it's not in the right form. Okay, so the last example we'll look at is going to be a discuss, but first thing we're going to have to do is just complete the square to get it in the right form, and then we'll say what the vertex is and all that stuff. Okay, we've covered completing the square a couple times this year, so I'm just going to go through it. And if you need to take notes on it, just kind of take some notes as we go through it. All right, so first thing I said we should definitely make sure is that we're going to have x's on one side when we're done and y's on the other. Okay, now you only need to complete the square with one variable. Okay, only one variable is squared. It's either the x's or it's the y's. In this case, it's the x's. So let's keep the x's on the left. Let's put other things on the right. Okay, leave a little bit of room to complete the square. And now, does anybody remember how you figure out what to add to both sides?
Isn't it absolute value of 1/2 the number next to before?
Close. I think the idea of taking half of something is good.
It's half the coefficient of the linear terms.
Yeah, it's half. Take half of the number in front of x and square it. So what's half of 4?
2.
2, and square it?
4.
4. Now we added 4 on the left. What do you add on the right?
4.
Now you have to be careful because sometimes if there was a number in front of x, the first thing you would have done is factor that out. So if you had something,
2.
yeah, okay, if you had a 2 factored out, and let's say you said, okay, I'm going to add 4 here. What did you really just add on the left?
8.
You added 8. So you'd have to remember to add 8 on the right. Okay, that doesn't happen here. Right? Now, this should factor nicely. What does x squared plus 4x plus 4 factor as? X plus 2 squared. Okay, so that looks better. And now, what could I do on the right-hand side?
Factor out 4.
Yep, we could factor out a 4, and I'm left with,
1.
now it looks exactly like it should. Okay, you always should have a 4 factored out, and then in parentheses, like that. So I will always make sure that you can factor out a 4 nicely from the right-hand side. Okay? All right. Now, when we discuss it, let's start. Well, actually, I have it all listed. Which way it opens: the vertex, the focus, the directrix. Okay, look in your chart. X is squared. The number on the other side is positive. Opens up. Okay. Now, I think without identifying H, K, and A, that's all we can really do quickly. So let's identify what those are. Okay. What's A in this case?
1.
A is 1. Yep. You would have, if this was like an 8, I would write it as 4 times 2. Okay, but it's just 4 times 1. Okay. What is H? Yes, it's x minus minus 2. Okay. H always goes with x, and it's the number after the minus sign. And what's K?
-1.
Yeah, K is always with the y, and it's what's after the minus sign. Okay, so for parabola opening up, our vertex is h comma k. -2, -1. Okay, our focus is h comma k plus a. So what is our focus? -2 comma what?
1. Or no,
0. Okay, our directrix is y equals k minus a. So it's going to be y equals what? Y equals -2. Okay, what's the distance between my vertex and my focus? Yep, they're 1 unit apart. What's the distance between my vertex and my directrix? Yeah, 1 unit. Okay, and that should be the same. Those two numbers we just said should be equal. Okay, any questions on it? Okay, if you had anything that you had to complete the square on the test with, that would be more of a bonus. Okay, so I might ask you one like this, but I would probably already have it in this form for you. Okay, you're not going to have to complete the square for a regular question, at least not for parabolas. And that's just practice. Does anyone need practice just completing the square, not doing a parabola problem? This is one where you would factor out. Well, maybe let's just do it. What do you do first here? Even before that, move the 4. If you factor out a 3, what are you left with? And what's the magic number I'm going to add? 4. And what about on the right? 12. That's the important thing I want you to see. Okay? And now you just finish it up. Okay, that's not a parabola problem because it doesn't have an x and a y. It's just to complete the square. Okay? Hey, any other questions on parabolas? All right, so it's good that we can kind of do this one, kind of get it out of the way, and you can practice with it, because then ellipses and hyperbolas are a little different, but I think they're different enough. It's probably better that you don't remember how to do parabolas, and we start fresh with ellipses and hyperbolas, because then you can get confused. All right, so the homework, it's on 386 in your packet. Okay, 11 to 18, that's all matching. So don't think you have to draw all those, it's just matching. 19 to 31, just the odds. Okay, and remember, they ask you to find the lattice distance. Don't do that. Okay, you don't have to find the lattice distance. 37 to 43 odd. And then 47 and 55. So I'll be after school today. Okay, if anybody needs to come see me for extra help or finish anything up. Otherwise, we'll review that tomorrow before our test.